Good day to you children. In today's class, we'll be learning about angle sum property of a triangle. The angle sum property of a triangle refers to the sum of all the interior angles present in a triangle. As you have learned before, a triangle is a polygon with three sides. So the triangle, any triangle has three sides and also three angles. If we were to draw a triangle, then this is the figure of a triangle which has three sides and three angles. If we were to name it, then triangle X, Y, Z has angles X, angle Y and angle Z, and the sides of the triangle are XY, YZ and XZ. So now the angle sum property of the triangle says that the sum of all the three angles of the triangle, that is angle X plus angle Y plus angle Z, is equal to 180 degrees. So write down the statement of the theorem. The sum of all the interior angles of a triangle is 180 degrees. This is a theorem which you learned in last year, so we are going to study it once again. Now before we prove it, let us write down what is given to us. Given triangle XYZ. You can draw a triangle and give it any name of your choice. I have given it XYZ. You can name it ABC, PQR, TUV, anything. So given triangle XYZ, to prove X angle X plus angle Y plus angle Z is equal to 180 degrees. To prove this, we will be applying our knowledge of parallel lines and transversals. So now a little bit of construction is needed here. Construction. Draw a line AB parallel to YZ passing through X. So now let us draw a line AB parallel to the side of the triangle YZ, which is passing through our vertex X. So using our scale, let us now draw a line parallel to YZ like this. Since we are constructing or drawing a line, a separate line which is not the part of our triangle, we are using dotted lines. Okay, this differentiates the constructed part here. So this is our line AB, which is parallel to YZ, and it passes through or touches the triangle at vertex X. So now let us prove it. The next part is proof. AB is parallel to YZ. AB is parallel to YZ, and XY and XZ are the transversals, right? AB is parallel to YZ, XY is the transversal. xy is the first. Let us only consider the transversal xy. Now if you look at the figure, xy is the transversal and AB is parallel to yz. So the angle y, this angle y is equal to angle AXY here. This angle y is equal to angle AXY because they are alternate angles. So let us write it down. This implies angle y is equal to angle AXY because they are alternate angles. Similarly, AB is parallel to YZ and XZ is the transversal. Now if you look here, then angle Z will be equal to angle BXZ because they are also alternate angles. So let us write that down. XZ is the transversal. This implies angle Z is equal to angle BXZ. So if you look at the figure, then AB is a line and these are the two line segments standing on the line which form three adjacent angles. Since the three adjacent angles are formed on top of a line, their sum will be equal to 180 degrees because they are a linear pair. Therefore we know that angle x plus angle AXY plus angle, name this as result 1 and this as result 2. The reason is once again same here, alternate angles. So angle x plus angle AXY plus angle BXZ is equal to 180 degrees because they form a linear pair. But from our result 1, we got that AXY is equal to angle Y and BXZ is equal to angle Z. So this implies angle X plus angle Y plus angle Z is equal to 180 degrees from results 1 and 2. This is a very important proof, children, so make sure that you practice it multiple times. If you have any doubts, then please go pause the video or rewind it and go through it many more times until you understand it. It is a very, very important proof here. So we'll look here. We needed to prove x plus y plus z, that is the sum of interior angles is 180 degrees. Our proof got us the result which was required. So the sum of interior angles of the triangle, no matter what their measure is always equal to 180 degrees. Hence, proved. This is the theorem. Now there is another theorem. Regarding exterior angles to a triangle. Theorem on exterior angles. When the side of a triangle is produced, then you get an exterior angle. So the theorem states that the exterior angle is equal to the sum of interior opposite angles. So if you were to draw a figure to understand this theorem, in the last year you also proved this. You proved this theorem too. But this year you don't have the proof for this theorem, only for the angle sum property of the triangle. You have the proof for that theorem only. So now, if I were to draw a triangle, then say this is our triangle PET. This is our triangle PET. And now I am going to extend one of its sides. Say I will extend the side EP. So I extended the side EP. Now this angle here, this obtuse angle which we get here is called as the exterior angle of the triangle. So now say this point be Q. So the angle QPT, according to the theorem, the exterior angle, that is angle QPT, is equal to the sum of interior. Interior means the angles which are present in the interior part of the triangle. So in the inside of the triangle there are 3 angles, but the exterior angle is always equal to the sum of interior opposite angles. To this exterior angle, these are the opposite angles, interior opposite angles. So our angle, if you were to write the relation mathematically, so our angle QPT is equal to angle E plus angle T. Not angle P is excluded here. If I extended the side E, if I extended the side E here like this, then this exterior angle FEP would be equal to the sum of the angles P and T, because they are the interior and opposite angles to this exterior angle. The angles which are on the interior of the triangle and opposite to the given exterior angle. So if I were to write that relationship, then angle FET is equal to angle P plus angle T. So the theorem states once again, the exterior angle drawn to a triangle is equal to the sum of interior opposite angles. So in the upcoming problems which we will be solving, we will be making use of both of these theorems. So now coming to your solved examples. The first question, in figure QT is perpendicular to PR. Given in triangle PQR, QT is perpendicular to the side PR and angle TQR, that is this angle TQR is equal to 40 degrees. Angle SPR, this angle, is equal to 30 degrees. Our job is to find the values of X and Y. So first solution, let us write down what is given to us. Given QT is perpendicular to PR. This implies whenever this is perpendicular, then the angle formed at that vertex will be equal to 90 degrees. So this implies angle QTR is equal to 90 degrees. So now, and then they are also given us that angle TQR is equal to 40 degrees and angle SPR is equal to 30 degrees. So now in triangle QTR, in this triangle QTR, we know the values of two angles and we can find the value of X here, right? Because sum of the three angles of a triangle is always equal to 180 degrees. So in triangle QTR, angle TQR plus angle QTR plus X is equal to 180 degrees, because the reason is angle sum property of a given triangle. Angle sum property. So this implies angle TQR, which is given to us 40 degrees, plus angle QTR is equal to 90 degrees plus X is equal to 180 degrees. So this implies 40 plus 90, 130 degrees plus X is equal to 180 degrees. This implies X is equal to 180 degrees minus 130 degrees, which is equal to 50 degrees. This is our required solution. Name it as result 1. So now to find angle Y. If you look at the triangle PSR, look at the second triangle. There are various number of triangles formed in this figure. So in the triangle PSR, the side RS has been extended, right? So angle Y is exterior. If we neglect this part, then angle Y is the exterior angle to this triangle PSR. And from the theorem of exterior angles, we learned that exterior angle is always equal to the sum of interior opposite angles. So using the theorem, in a triangle PSR, angle Y is exterior to the given triangle. Therefore, Y is equal to angle SPR plus X. So angle SPR, we know that angle SPR is 30 degrees plus angle X is equal to 50 degrees. We got it from 1. Result 1. So Y is equal to, this implies Y is equal to 80 degrees. This is the required result. So our job was to find the values of X and Y. We got X is equal to 50 degrees and Y is equal to 80 degrees. This is the solution to the required question. So in this single question, we applied both the theorems which we learnt. So before we forget, let us write the reason. Exterior angle theorem. Exterior angle theorem. This is the reason. Exterior angle theorem states that the exterior angle is equal to the sum of interior opposite angles. In the second question, in figure, the sides AB and AC of triangle ABC. Yeah, look at the triangle. The triangles ABC, the side AB and AC have been extended to the points E and D respectively. If the bisectors BO and CO, the line segment BO is the bisector of the angle EBC and CO is the bisector of the angle DCB. So if the bisectors of the angle meet at the point O respectively, then prove that angle BOC, this angle BOC is equal to 90 degrees minus half of angle BAC. So solution. First let us write down given triangle ABC and BO and CO are angle bisectors. We know this much, right? And look here, in the triangle ABC, I have named the interior angles as X, Y and Z. This will make it easy for us to use those notations. Okay, now since BO bisects angle EBC, we have, since it is bisecting it, bisecting means it is the angle has been divided into two equal parts, we get angle CBO, this angle CBO, this angle is equal to half of angle EBC. Agree? Because BO has bisected the angle. So these two parts are equal to one another. They are halves of one another. So angle CBO, only this part will be equal to half of the whole angle EBC. But angle EBC is a linear pair with angle Y. They are a linear pair. Angle EBC forms a linear pair with angle Y. So this implies angle CBO is equal to half of 180 degrees minus Y, because they are a linear pair. Let us write down that reason. So on simplifying, we get angle CBO is equal to half of 180 degrees is 90 minus Y by 2. Name this as result 1. using the same steps as before. Similarly, CO bisects angle DCB. This implies angle BCO. Angle BCO is equal to half of angle DCB. Half of angle DCB or angle BCD. This implies similarly angle DCB is a linear pair with angle Z of triangle ABC. So angle BCO is equal to half of 180 degrees minus Z because they are a linear pair. So on simplifying, we get angle BCO is equal to 90 degrees minus Z by 2. Name this as result 2. Now in the triangle BCO, that is the triangle formed by the angle bisectors, we have angle BCO plus angle CBO plus angle BOC is equal to 180 degrees because angle sum property, the sum of the interior angles of the triangle is always equal to 180 degrees. So angle sum property. From 1 and 2 we have angle BCO is equal to 90 degrees minus Z by 2 and angle CBO is equal to 90 degrees minus Y by 2 plus angle BOC which is equal to 180 degrees. So this implies 90 plus 90, 180 degrees plus angle BOC minus Z by 2 minus Y by 2 is equal to 180 degrees. 180 degrees on the either sides of the equation cancels out. So we get angle BOC is equal to Z by 2 plus Y by 2. Both are negative, so on transposing to the right hand side they will become positive. So this implies angle BOC is equal to half is common angle Y plus Z. Now angle Y plus Z, apply the angle sum property to the triangle ABC. So in that triangle ABC, angle X plus Y plus Z is equal to 180 degrees. So we get, this implies angle BOC is equal to half of 180 degrees minus X because X plus Y plus Z is equal to 180 degrees because of the angle sum property. So Y plus Z will be equal to 180 minus X. So this implies angle BOC is equal to half of 80 degrees is 90 degrees minus X by 2. So now the angle X is equal to 90 degrees minus half of angle BAC. This was our required solution. Angle BOC is equal to 90 degrees minus half of angle BAC. This completes your solved examples for the following section. So now your homework for the day is question number 1 or the first main from the exercise 3.3, which says in figure sides QP, that is this sides QP and RQ of the triangle PQR are produced to points S and T respectively. So thus the exterior angles formed, that is angle SPR is equal to 135 degrees and angles TQR or PQT is equal to 110 degrees. Your job is to find the value of angle PRQ. This sum can be solved in two ways. One of the ways is that here, look here. This angle, exterior angle PQT forms a linear pair with angle PQR. So similarly, angle SPR forms a linear pair with the interior angle PRQ. QPR. So using that you can find the values of angle P and Q first and then apply the angle sum property of the triangle to the whole triangle PQR to find the value of R, or you can use the property of exterior angles, that is the theorem of exterior angles, to find the value of angle PRQ. So in the next class I'll solve the rest of the sums belonging to the exercise 3.3, and that will be our last class for this chapter. Thank you.